Welcome to this Thursday evening office hour with a slightly different regional focus than these sessions often have. I will still be talking about some California and Western U.S. weather at some point during the hour, but today I really wanted to focus on Hurricane Helene, which is imminently going to make landfall in the Big Bend region of Florida over the coming hour or so, as well as another hurricane that has caused some devastating flooding along the Pacific coast of Mexico today, somewhat unexpectedly, now making the second year in a row that the city of Acapulco has been affected by a rather unexpected hurricane related disaster. So I think that also deserves conversation, given that some of the underlying factors are similar, even though these are two very different contexts and two very different storms. The other part of this is that a good chunk of the interior southeastern U.S. will likely experience a historic flood event as a result of Hurricane Helene and the combination with the very heavy rainfall that's fallen in the days leading up to this hurricane. In fact, an event that could be genuinely catastrophic for a lot of parts of the southern Appalachian mountain region, including western North Carolina, parts of Georgia, and adjacent states. This is a major weather event of national significance, and there are multiple major weather events in North America right now between these two hurricanes. Of less note because it is less immediately damaging, but also the western United States continues to experience record-breaking temperatures again in yet another month. Phoenix potentially seeing some of its latest 110-degree days. Denver rounding out its hottest September on record, just to name a few. I probably won't talk very much about that today, but just wanted to highlight that this isn't the only weather of significance going on at the moment. There's quite a lot to talk about. In fact, even in planning for this evening session, one of the reasons why I scheduled it when I did was because this is right around when Hurricane Helene was likely to make landfall, and that turned out to be a relatively good prediction because I'll be able to show you live right now this massive hurricane approaching the coast, but also because there were so many events going on, both in the U.S. and around the world, that I wanted to have some time to consider the broader picture as well before speaking with all of you this evening. So, as always seems to be the case in our warming world, there's a lot going on, but a disproportionate amount of it right now is in the U.S., even though it's not necessarily in the western portion of the country at the moment. And I have a bunch of graphics pulled up that I'd like to show. One challenge is that a lot of the websites, both the government websites, so the NOAA servers, and some of the private, independently operated weather information connoisseurs and purveyors, if you will, those servers typically now become overloaded every time there's an extreme weather event and when millions of people log in. This is a bit ironic, given that I'm more used to talking about how we need to adapt our built physical infrastructure for a warming climate, but it turns out that's also true for our information technology infrastructure as well, and likewise, it's built more for typical and average conditions than for extreme conditions. And again, this is not because there's any physical damage to the internet in any meaningful sense. This is just because there is such extremely high traffic to websites, weather-related websites that don't usually receive this level of traffic, that they simply are not designed to handle the load. And frankly, that really shouldn't be the case for underfunded government IT teams, but perhaps that's a question for another day. What I would like to do is again acknowledge the sponsor of this channel, the Reask, which is a climate tech company that's helping companies to rethink extreme weather risk, quite relevant given the conversation we're going to have today. So I think what I would like to do is just launch into some imagery, because I know that's what a lot of you would like to see. I do want to talk a little bit about the outlook for California. The TLDR version, essentially, is that California looks much warmer than average for the foreseeable future, with little or no prospect of rain anywhere in California in the next couple of weeks. So those predictions for a warmer than usual and perhaps later than usual start to the rainy season, I should say warmer than usual fall and later than usual start to the rainy season, certainly appear to be coming to fruition at the moment. And although there are no major offshore wind events currently on the horizon for the West Coast, fire risk will be rising once again, and we do see some new wildfire starts popping up as recently as this week. So no extreme fire weather conditions around the West right now, but the warm and dry autumn that has already started to unfold and is likely to continue for at least in the coming weeks will set the stage for an unusually late fire season across the interior West, and I guess we could call it fashionably late fire season for coastal California. That's less unusual here, but what is unusual is the magnitude of the warmth we're about to see, and that combination with the wet conditions of the past couple of years leading to lots of extra grass and brush growth in these Santa Ana offshore wind-influenced fire corridors we've been talking about in some of these recent sessions. So maybe that's all I need to say about that actually tonight, which is that it's been warmer than average in California recently. It's going to be persistently warmer than average for the next couple of weeks. Occasional weak breezes, but really mostly just warm and dry, record warm. In some places, probably not so much along the coast in California, but across the interior West, this is pretty darn anomalous for this time of year. On the exact opposite end of the spectrum now, I want to shift to the southeastern U.S. and Hurricane Helene, which is currently, at least as of last update, unless that changes, a Category 4 storm, meaning that the most recent update had sustained winds of 130 miles an hour, although I think that they're probably even higher at this point, maybe 140, 145 miles an hour based on some of the latest data. That is an extremely strong hurricane, solidly in Category 4 out of 5 territory, and is making a beeline for the coast. Now, as I mentioned, there will be a potentially devastating impact along the immediate coast in the Big Bend region of Florida, but the good news is the Big Bend region of Florida is the least populated coastal portion of the entire state. So that will be one mitigating factor there, although for the relatively small populated towns that are in the risk zone, this will be probably a catastrophic to a wipe off the map kind of event, unfortunately. The city of Tallahassee is not an immediate coastal city. Fortunately, it's got 100 feet or so of elevation, so that'll prevent the storm surge from affecting that city, but the city itself may be in the western eye wall of the hurricane and therefore could see really strong winds exceeding 100 miles an hour that could lead to a lot of damage and widespread power outages and forest blowdowns. This is actually a pretty heavily forested part of the United States, this swath from the northwestern Florida panhandle up into Georgia and the southern Appalachians. And the swath of 70 to 110 mile an hour wind gusts that might occur is going to be enormous in this heavily forested area. So there could be tremendous damage to the forests here and to the urban tree canopies, and that will result in power outages that could last weeks and maybe months in some places. So this is a big, big deal, even for places that aren't usually accustomed to the traditional hurricane-related hazards along the immediate coast. So Tallahassee is probably the first city of substantial size to be affected by the storm, and although it won't see a big storm surge, or any in the city itself because you're 100 feet up, everything within about 20 feet vertically of the Big Bend coast in Florida could be underwater within the next few hours, and that is an extremely large storm surge. Will probably be the largest storm surge on record for this entire segment of coast. 20 feet again is well into, if not above, the second story of buildings. So imagine the ocean this morning and the ocean this evening having a two-story increase above the mean tide line. And unfortunately, it looks like the storm is coming through at high tide, which might mean that a few spots even see storm surges. Well, technically the storm surge would still be about 20 feet, but the thing you care about is how high is the water storm surge plus the tide level, and that could end up being even higher than 20 feet above mean sea level in some cases. So this is the language out of the National Hurricane Center. devastating and unsurvivable. Catastrophic and unsurvivable storm surge in this region. It's worth reflecting for a moment on what this would look like if this exact same storm were 100 to 150 miles further east and directly affecting the Tampa Bay area, where they are still experiencing major and perhaps even record-breaking storm surge, but it won't be 20 feet deep or even necessarily 15 feet deep. It'll be, in most places in the bigger cities, 10 feet or under. Now, 10 feet is still a life-threatening storm surge, but at least it's one where usually if you're up on the second story, you'll be okay. But with 20 feet, even the second story probably isn't enough. So just to reflect for a moment, this is one hazard that you really don't have to think about in California. This is definitely something that is a regional threat, just like you don't have to worry too much about wildfires in some locations. You don't have to worry too much about catastrophic hurricane storm surges in others. But without further ado, I do think some folks want to see the imagery, and so I'm going to share that. I'm going to share my screen. You'll see I still haven't fixed the infinite mirror problem. Sorry, folks, it's been a little busy lately, but start with some satellite imagery, jump over to the radar, and then there's some other things I'd like to show as well. And again, all of this is live. None of this is pre-recorded. You'll see it unfolding, as you always do in these live streams, live on the screen. There's your infinite mirror. There's the wrong tab. And here we go. So I may momentarily just verify that you're seeing what I'm seeing here. Be just a second before I go back. Sometimes I have to do this just to ensure. There we are. Okay, sorry for the back and forth. So this is the storm in question. Again, this is from the pretty amazing weather repository of tropical tidbits run by Dr. Levi Cohen, who operates this website largely on the basis of donations and contributions. So if you're so inclined, I know he appreciates it. I also think the site is currently under major strain because there are a gazillion people watching this. So I'm trying not to refresh the page right now because I've lost the connection due to the number of connections. So I'm going to leave it as it is. But this is still live. It's auto-updating. This is Hurricane Helene. As you can see, very close now to the coast, the Big Bend coast in Florida. And I'm going to bring up my drawing tool, show a few features here. This, of course, is the current location of the eye of Helene. You can see let me get this so that it stays. You can see that this is roughly where the eye currently is. You see the hurricane moving from its previous position toward where the eye now is. The eye of the hurricane, since we don't talk about hurricanes as much, is the calm at the center of the storm. That's actually where this expression comes from, which is that there is a region of subsiding air, meaning downward moving air, as we know in California, where we have a lot of downward moving air. Downward moving air, subsidence is favorable for suppression of clouds and storms. But what you have in a hurricane is you have violently upward moving air, updrafts in the eye wall surrounding the eye. That's where the worst of the winds are, where the worst of the rains are, where you sometimes even see lightning, as we're seeing with this storm. But in the eye itself, immediately adjacent to that spiraling, usually circular or elliptical eye wall, what we have is air that moves downward. It's actually quite warm, even relatively dry air in the middle of the storm. This is how the vertical circulation of a hurricane works. You have a lot of upward motion in the eye wall. That's where the violent storm is. In the middle of the eye, in a well-developed hurricane, you can actually have clear, sunny skies and light winds and be surrounded within 50 miles in every direction by catastrophically strong winds over 100 miles an hour and violent rain bands. That is the nature of a fully fledged, well-developed hurricane. As you can see here, there is a well-developed eye, and it looks like there is at least a small region of clear skies, so actual clear skies. If you were in this eye right now, the sun has set in Florida, you'd be able to see the stars at the center of the storm. keep that in mind as we talk about all of the other kinds of extremely intense phenomena that are going on here. One other piece here is that this is a relatively short loop, and again, I don't want to change it for fear of losing it, but this storm has rapidly intensified. This hurricane shows a lot of classical characteristics of a major Category 3, 4, 5 type storm with very deep convection almost entirely surrounding the eye, so that's very tall tropical cumulus clouds and cumulonimbus clouds, so thunderstorms, even with some lightning, surrounding the center of the storm completely. That's those black and white and even purple colors you see around this region. You can see that it even kind of has that classic hurricane spiral, so you can kind of see that sort of classic, almost like the icon, the graphical icon for a hurricane, kind of looking rather textbook here. And the other thing you can see is that there is what is known as pretty good outflow. So one thing that you need is you need vertical ventilation. So the storm needs to breathe, if you will. And what you can see is that there's pretty good radial expansion in essentially every direction of that high cirrus layer. So this whole region here, you can kind of see that the storm, in a vertical sense, the air is rising in these intense rain bands around here, and the air is sort of diverging outward like this in a horizontal sense. So it's a little bit confusing since I'm mixing horizontal and vertical motions here. But the idea is that this is a very well-developed storm that unfortunately got its act together right before it hit the coast. So there was some hope that maybe this thing wouldn't fully latch on to the very favorable environmental conditions, low wind shear, high humidity, and more importantly, extremely high ocean temperatures. In fact, I'll come back to that in a minute. Ocean temperatures in the Gulf of Mexico are literally warmer than they have ever been before in recorded history. As of right now, that's the kind of fuel that's fueling this high-end Category 4 out of 5 hurricane. Let me put it this way. If this storm had had an extra 4 or 5 hours over this bathtub warm water, there's a pretty good chance this storm would have become a Category 5 out of 5 storm. This thing was limited only by the amount of time it had over that record warm water. So again, this is going to be a devastating storm for some communities and may produce some really devastating wind damage and floods up into this region, but we're fortunate that this storm isn't making landfall. Instead of this section of coast right around here, we're lucky that the storm isn't instead making landfall down here toward Tampa Bay. That would be just an utter catastrophe. Or for farther southeast down the coast by Miami, or over here off the map by New Orleans, or even farther west thinking about Houston. These are all places that would have fared very badly with a storm like this. Hurricane season's not over yet, though, and the water is still record warm in the western Gulf, so this may not be the last extremely intense storm of the season. So, and just to give a sense, we don't know exactly where along the coast this is going to make landfall, but at this point it looks like it's somewhere in that red arc of coast. The Tallahassee is, I believe, somewhere in this region. So again, not right along the immediate coast, but definitely could be in the path of the western eye wall, potentially, depending on how this storm wobbles. So if we kind of assume that there's some, the motion is going to look something like that, and Tallahassee somewhere in here, that definitely puts it potentially in the western eye wall. There's actually a hurricane warning all the way north up through Georgia to the southern suburbs of Atlanta, which is actually the first time that's ever been issued. Now, that's mainly because the Weather Service did not used to issue inland hurricane warnings officially. They would only issue them for the coastal counties. But it's a new policy change to, if conditions warrant, to issue them as far inland as a hurricane is going to bring hurricane force winds, which I think makes sense. The interesting thing is I'm not sure that they would have issued one previously for this region, even if that policy had been in effect in the past, because this is a particularly, as you may note, this is a particularly fast-moving hurricane. It's moving toward the coast pretty quickly, and so it's not going to have time to weaken fully before it makes it inland. And so this entire region could see wind gusts over 100 miles an hour. So it's going to take to here where the winds get below 100 miles an hour, but are still up to hurricane force. And again, as I mentioned, This part of the southeastern U.S. is very densely forested, and so there could be a huge forest blowdown in this region. All right, so the next thing I would like to show, and I'm going to briefly take a look at the questions here. Welcome, folks. Okay, good. So you're seeing what I'm intending. The next thing I'd like to show is the radar, and in some ways this is even more impressive for a variety of reasons that I'll get into. Okay. Wow, this is even more dramatic than when I looked before the session. So what is clearly apparent is that this storm is still strengthening. So I'm going to draw the coastline first. This is approximately where the Big Bend, maybe I've exaggerated that a little bit, so I'm going to, whoops, that's not what I wanted. I just want to illustrate where the coastline is. There it is. Because just to show, first of all, the storm is within an hour, probably, of making landfall. So it might not do so during this session, but it's going to come awfully close. But the other part is that the core of the storm, this is the heat engine of the storm still. It's still over water, and that water is bathtub warm, and it's shallow, but it doesn't matter because the storm is moving very quickly over it, and it doesn't have time to mix up the cooler water from beneath. So as this storm moves, it looks like it's maybe even wobbling a little bit back in this direction. That would bring it back closer to Tallahassee in the western eyewall. But what I want to reiterate, and I'm going to draw the coast again just because that's a really important piece of this, is that the northern and western eyewall, so this feature here, I'm going to draw around where it is in the last frame. This is like, this is pretty bonkers. It's a very contiguous band of, this is essentially like the thunderstorm of your nightmares. So this is essentially a contiguous band of almost non-stop strobe lightning associated with sustained winds of about 110 to 140 miles an hour over that entire region. That's just not good news, given that this storm is looking like it's continuing to strengthen. Lightning is not all that common in ordinary hurricanes. It's usually a sign of that the storm is actually continuing to strengthen and has particularly strong updrafts. This amount of lightning is even less common, and actually this is what I'm so surprised by. This has really picked up in the past couple of hours, which is absolutely not what you'd want to see. All of those lightning strikes and this extremely high reflectivity on the radar is indicative of just truly extreme winds. There's really no other way to put it. And given that the storm is continuing to strengthen, there are probably 140, 150 mile an hour winds somewhere in this region. And in fact, I'm going to zoom in. It's cool that you can do this. By the way, this is the radar site in Tallahassee. This radar site might not be usable in a couple hours, so as the power goes out or as the radar site gets damaged. Here's zooming in on this eye, which is a little bit mesmerizing. It's unusual to get such a complete, uninterrupted view of the eye of such an intense hurricane. But there's something else that I wanted to illustrate, and that you may note in this region on the western eyewall in particular. Take a look at the edge of the eyewall here. You see there's like a serrated edge. And what those, I think, are, we've seen these before in very intense landfalling hurricanes, are they're known as mesovortices. So essentially, obviously, the hurricane itself is one giant vortex spinning like this. That's pretty obvious just by looking at this radar imagery. But along this line, there are little mini vortices that are essentially doing this. And these can essentially be tornado strength winds that occasionally bring even stronger. So these are like tornadoes essentially that are several miles wide. So small relative to the size of the hurricane, but enormous relative to the size of a typical tornado. And they can have winds that are around the maximum wind speed of the hurricane or even a little bit higher. So these are multiple mile wide swirls of winds in the 130 to 150 miles an hour range, possibly. That is a sign of a violent hurricane by any means. And let's actually see if we can illustrate this more directly. Oh, here we go. Yeah, that's pretty interesting. So now what I'm seeing is your traditional radar view on the left, but now I'm showing the winds that the radar is measuring. So instead of the intensity of precipitation, which is on the left, the reflectivity, looking at the winds on the right, and wow, that is a lot of lightning, first of all, for a hurricane. But you can see, I'm going to pause this in one of these frames here so we can more clearly see that, because it's kind of, yeah, so you can kind of see these different linear features. These are sort of associated with those little rotations in this band, so you can really see this more readily with this imagery here. In fact, let's use the inspector tool to see some of these wind speeds. So you were seeing like 150 miles an hour, 155 miles an hour. I was seeing a 165 earlier. Let's animate this forward a little bit. So we have this earliest frame. Let's take a look at this, because this is where some of the strongest winds were closer to the radar. What are we looking at? So that's 169 miles an hour. So that's a directly measured wind speed. Now, this wind is not the surface wind. So this is a wind being measured by the radar. This is how fast the raindrops are flying, literally, about 10 to 20,000 feet above the ground. But still, that means that at some point in the storm, there are winds of 170 miles an hour above the ground. If you go over here on the quote-unquote weaker western edge, it's still 115 mile an hour or so swirls here. So, but on the stronger eastern eye wall, wow, that's actually even higher. That's 174 miles an hour. So, let's do the math here. Usually there's about an 85% reduction from winds at this high altitude to the surface, which would tell us about what our surface wind speeds are. So multiply 174 by essentially 0.85. And sorry, I am doing the math on my calculator, since I don't trust myself to do the arithmetic live. But that's roughly going to give us our surface wind, and that's right around 148 miles an hour. So this thing is plausibly at the very high end of Category 4 and not all that far from a Category 5 storm. I don't think it quite has time to officially get there, but for all intents and purposes, this is a borderline Category 4, Category 5 storm. Wow, that is pretty amazing. All right, so I'm going to reanimate this. No zombie hurricanes, please. But just to zoom out and give you perspective, this is how big the storm is. It's enormous. You know, there's heavy rain extending all the way from Panama City, and you actually can't see it on this radar, but all the way down toward well south of where it looks like on the radar, so all the way down toward the southern Florida, just outside of the range here. So that is, whoops, that's not what I meant to do. I have to go back to Florida now. Sorry about that, folks. It jumped to Colorado. Just need to go back to Tallahassee, and there we go. Okay. Yeah, so here's the frame I meant to leave you with for now. So I'm going to move on, but this is one of the more extreme radar presentations I've seen, and the thing that's really striking to me, just zooming in on this, just look at all those lightning strikes. There's just literally lightning. If you zoom all the way in, there's just lightning as far as the eye can see. Okay, some other data that I want to show here is, what do the global ocean temperatures look like right now? Well, this doesn't give us historical context, so let me put the scale on here. That's more important than the title. There we go. These are temperature anomalies relative to the recent baseline. So again, this is even relatively accounting for some of the global warming we've already seen. So this is adjusting already for some of the recent warming oceans And yet there's still an awful lot of orange and red on this map. In particular, two things I want to show. Of course, Helene is right here where the X is. But generally speaking, the whole Gulf of Mexico is like extremely warm, and it's already normally bathtub warm this time of year. So that's actually saying quite a lot. The other piece is that the rest of the Atlantic, I mean, I'm not even going to draw a line actually. I'm going to draw a circle around the entire Atlantic basin. It's just extraordinarily warm, as much as 4 to 5 degrees centigrade above average. Again, multiply by your favorite conversion factor for Fahrenheit, but this is kind of a shockingly warm ocean. We've talked about this before, but this is sort of where when the chickens come home to roost, is when you actually have a storm that's feeding off of it, like we have Helene here. The other thing I want to remark, because I want to talk about another hurricane now, there's also Hurricane John off the west coast of Mexico, roughly in this region here, and I also want you to note that the ocean in this region is far above average as well. The other thing, and this is kind of unfortunately split on the map, but the Mediterranean also on fire here. That contributed to the record-shattering catastrophic flood event in Central Europe a couple weeks back. And this incredibly warm region, I mean, even blowing all of those regions out of the water in the Western Pacific. This is in a region known as the Kuroshio Extension. It's a western boundary current, so the ocean at the surface flows like this. As you might imagine, this is a warm current because the water moves northward from the tropics, so brings warm water and therefore warm air northward. So Japan, for example, gets a lot hotter and sees more hurricanes than it would otherwise at its latitude. Notice that central Japan and California, well, I should draw a straighter line, are essentially at the same latitude, but Japan, southern and central Japan, are at high risk of hurricanes, can see major hurricanes, whereas California generally does not. Why is this? Well, that's because the western boundary current brings warm water to the north in the western Pacific and cool water to the south along the west coast. That's one of the reasons why California has its characteristic weather. Same thing on the east coast. The Gulf Stream brings warm water to the north along the eastern seaboard. Again, the equivalent ocean on the eastern seaboard of the U.S. much warmer than California. And in Europe, it's a little bit different because you actually have so much warm water transport from the Gulf Stream that it still keeps Western Europe a little bit warmer than average. Anyway, that's a global climatology and ocean circulation lesson. But the reason I mention this is because the water is going like this. This is a relatively cool part of the North Pacific, but it is over, in this case, 5 centigrade above the long-term average. That's just an enormously huge anomaly. But the tropical Western Pacific is also warmer than usual, and then we have this developing La Nina signature, so pretty much one of the only places where there's cooler than average water is because of La Nina. There's also some cooler than average water off the coast of South America, but this is not a very large region compared to the rest of the world. But the Kuroshio Extension, watch this space. This is an interesting thing to be monitoring, and I'm not entirely sure what to make of it. Stay tuned. But right now, the two pieces I wanted to really emphasize are the bathtub warm, record warm water in the Gulf of Mexico, and also the much warmer than average temperatures off the coast of Mexico. And so what I want to see is if Tropical Tidbits is back online to take a look at, let's see here, Hurricane John. Let's see, it may just be that the website is having difficulty. Yeah, okay, well, I don't think I'm going to be able to bring that up. So let me get to that in a moment. So going back to Helene, so again, let's take a look at the satellite just to see this is a live update. I mean, this just looks pretty bad. We saw that on radar. Here's an outlook from, and I'm going to zoom in a little bit. Again, different part of the U.S., but this is from the National, this is actually from what is known as the Weather Prediction Center, which is a curiously named center within NOAA that predicts specific kinds of weather, but not others. But in any case, they do good work. Here is an outlook for flash flood risk in the southeastern U.S. And the reason I'm bringing this up is that whenever purple shows up, the purple color, and sorry, by purple I mean pink. Maybe I'm going colorblind. But the purple swath And again, I realize this map for people who do have red-green color blindness is perhaps unreadable. I do wish the federal government got better with their color map accessibility. But anyway, the purple region, actually, I'm just going to, sorry, I said purple again, I mean pink. I'm just going to outline it so it's more obvious for everybody. Essentially is this area here. So this area extending from the Florida coast, including Tallahassee, upward north through Georgia, including the Atlanta metro, and then along the southern Appalachians, up through and including western North Carolina, including Asheville. When you see that large of a pink area encompassing literally about half of the state of Georgia and a pretty good chunk of Florida, North Carolina, and even a little bit of South Carolina, that's a really big sign that something big is percolating, because when historically this branch of NOAA has issued these sorts of high risk events for broad regions, they typically, more often than not, result in catastrophic flash flooding. And so that is very much the expectation. Places in and near Asheville, for example, are already experiencing, due to a rain event which was known as a predecessor rain event in this area that preceded the storm. Again, the hurricane is all the way down here still, and yet already up here there's been catastrophic flooding. So as the storm moves northeastward like this, upslope, because of course the Appalachians sort of go like this, and again I'm being very approximate here, the flow, actually let me let that, so if the axis of the Appalachians is like this, the storm is bringing Gulf moisture like this. And so unfortunately on the eastern slope of the Appalachian Mountains, along this axis, this pink axis right along here, filling it in with red, that's upslope flow. That's like an atmospheric river hitting the Sierra Nevada from the Pacific, for example. But this region is actually not as accustomed to extremely high rain rates, believe it or not, to the same extent as some of the highest mountains in California are during our winter atmospheric rivers. So even though you might see, 6 to 10 inches of rainfall, there are parts of California that see that every winter. That's true, but it is all relative, and in this case, this is likely to be the heaviest rainfall event ever observed in this region and could include some widespread catastrophic flooding. In fact, I may even bring up the Weather Prediction Center website just to illustrate just how strong the wording is for this region, because otherwise I wouldn't be focusing on it. Here is the headline. Widespread and catastrophic flash flooding likely. Again, this is that pink region above. So that is not language that is used lightly, and I tend to think that this could be a flood event, at least locally to regionally, on the level of what we just saw in Central Europe. So there's also, because this is mountainous terrain, a growing risk of landslides. So flash flooding, river flooding, and major landslides likely. The landslides, of course, more likely as you get up into the southern Appalachians, higher elevations, more steeper terrain, but extremely serious flash flooding possible everywhere else. And unfortunately, when this agency draws the pink contour, usually bad things happen. And this is one of the largest, if not the largest, area encompassed by one of these pink contours that I think I've ever seen. I'm not quite. Somebody probably has the stats on that, but this is really looking like it could be, in some ways, the most deadly or potentially deadly effect of this specific storm event. Okay, so I want to just give you a big picture for a moment, switching gears, just looking at the western U.S. for just a moment, and I still want to talk about Hurricane John in western Mexico. In fact, let me actually use this satellite tool to do that. I wasn't thinking this is probably a good alternative. Okay, let me just pull up the right imagery here. I probably want the short wave, long waves. There we go. Okay, this is what I wanted. Let me just see if there's a zoomable sector down here. Yes, there is. Okay, so here is the other hurricane of major interest. This is, of course, so the west coast of Mexico is roughly here. Obviously, I drew that crudely. Let me draw it better without the timer. So you can kind of faintly see it with the blue outline, but I'll just to give a sense of where it is. This is important because there are steep coastal mountains right along the coast in this part of Mexico. So here, once again, tropical moisture meets upslope flow is a recipe for a flood disaster. The hurricane itself is over here. It's a little bit hard to tell. Obviously, this is not as strong as Helene. I think John is like a Category 1, so a minimal hurricane. But of course, when it comes to rain, the category, the wind intensity doesn't really matter. It's just a matter of how much moisture are you able to flux inland. And again, the axis of the coastal mountains is a little bit inland of the coast like this. This hurricane is pumping the moisture again up against the mountains, including in and near Acapulco, which has experienced now the second widespread devastating hurricane event in as many years. I believe that was just last year, that Hurricane Otis unexpectedly intensified into a Category 5 out of 5, again, the top end of the scale storm, and brought catastrophically strong winds to the city itself, blew out a lot of high-rises, devastated the city, but mainly from a wind. There was some flooding, but that was actually more of a wind event. This one, much less of a wind event, but now a catastrophic flood and landslide event. So now this is a city that's now had to deal with two very different hurricanes that are probably very destructive in their own right. And again, this was a storm that's nearly stationary. So this low, I don't know exactly where the center of low pressure is. I'm kind of guesstimating here. It's just sitting there. So this is the exact opposite of Helene in the sense that Helene is making a beeline, as we saw on the other maps. But John is sitting right here and just continuing to bring torrential downpours to a pretty good chunk of this portion of Mexico, which again is quite mountainous. There's a lot of mountain roads, there's mountain passes, but even the city itself, once you get away from the beach there in Acapulco, is a pretty hilly, if not mountainous, city. And so this is causing major problems with widespread severe flooding and landslides here. So I don't have as much information on what has transpired as I do in Florida right now, but this is another story to watch. And it is notable that, again, two regions experiencing two catastrophic flood-related events. In this case, not so much of a wind event as Helene will be for Florida, but in both cases, oceans are, in the case of the Gulf of Mexico, record warm, and in the case of Western Mexico, the Pacific is merely well above average. But what else is new in this warming world? So just wanted to point out that perspective and also to reiterate that when we do look at these extremely anomalously warm sea surface temperatures, very warm oceans are functionally hurricane fuel. And we do know there is recent evidence. In fact, let me bring up the camera. I'm going to speak directly to you once again, so you'll see me on camera again, and I'll be able to see the comments. We know from recent research that hurricanes in many basins, so in many different ocean regions of the world where they occur, are intensifying more rapidly than they used to. This is actually an observation rather than a prediction. It's an observation that is consistent with predictions when we use predictive models that are capable of adequately representing the really complicated and fine-scale physical processes in tropical cyclones and hurricanes. But it is nonetheless one that is corroborated by observations of hurricanes that have rapidly intensified as they approach landfall more often and to a greater degree than they used to in recent decades. That's a pretty big problem because it means that A, the storms are strengthening on approach rather than weakening, and there are certain reasons why you'd rather be in a weakening hurricane of an equivalent intensity than a strengthening one. Part of that is because the strongest winds tend to be more able to mix to the surface when the storm is strengthening with very strong convective updrafts versus weakening, where those momentum transfer of those very strong winds high up in the atmosphere isn't quite as pronounced as it is in a weakening storm. but also because it means that from a preparedness perspective, it makes it really difficult to know what to do if a storm strengthens extremely rapidly from a tropical storm or a Category 1 hurricane to a major hurricane literally overnight, as increasingly occurs and has occurred with this Helene, which is now making landfall in Florida, and occurred last year. I believe, again, it was last year with Hurricane Otis, that really devastated Acapulco unexpectedly. And I don't use that term lightly either. I think that it's often very overblown that such and such storm hit without warning, or the forecasts were wrong, nobody saw this coming. Almost always the meteorologists saw it coming and tried really hard to communicate it to the folks who would be able to implement the correct emergency response and evacuation measures. But often those warnings are not heeded still, even in this day. But in that case, it was a relatively rare case where it was truly a forecast predictive failure. There was not expected to be, by any means, a major hurricane, let alone a full-fledged Category 5 hurricane, making landfall directly in that significantly populated area, and yet it happened anyway. So that is kind of the nightmare, and I talked about this last year. A storm strengthening overnight from a minimal hurricane to a Category 5 hurricane and then making landfall unexpectedly in a highly populated place truly is a nightmarish scenario, because it means that you can't implement, even if you try, even if you are doing your best, you can't fully implement the kinds of evacuations and preparedness measures that you would really want to minimize loss of life and property damage. And so that just didn't happen. People thought it was going to be a rainy and breezy day and ended up having to ride out a Category 5 hurricane. Now, the good news was, despite the devastation and there were deaths, Acapulco is not really a storm surge vulnerable city, so people could escape whatever flooding did occur by going up to a higher floor or going up the hills. If that happens in a city that is storm surge vulnerable, so if we ever see a scenario like that in the Tampa Bay area or in New Orleans, I know we saw something analogous to this, of course, with Hurricane Katrina, but believe it or not, that was not the worst case scenario hurricane for New Orleans, because it was a weakening storm and it actually hit east of the city rather than a direct hit, despite the catastrophe that resulted. The other nightmare kind of scenario would be Houston, Texas. Sorry, I gotta deal with some issues in the chat here. Hold on here, just a minute. This is the first time I've had to do it, but well, there it is. Apologies, folks. Sorry about that. So the reality is that we see these kinds of rapid intensification events near major urban areas as one of the really scary things that might be happening more frequently in a warming climate, because it's bad enough if you get a Category 3, 4, 5 Category 3, 4, 5 hurricane near a major city, but the real nightmare is that you don't have time to get people out of harm's way. Now, of course, there are still cities in the world where even if you have the warning, there aren't many places to go. So certain cities in South Asia are still really vulnerable to it. But this used to be a really big problem in Bangladesh, where some of these very powerful storms caused huge storm surges in the highly storm surge vulnerable river deltas in the region where millions of people lived, and there would just be these horrific death tolls. Tens to even hundreds of thousands of people would perish in a single storm, mainly just because of the rising ocean level, the storm surge. There's been a lot of progress, tremendous progress actually. It's a real success story in Bangladesh with preparedness and not only prediction, of course, prediction and coordination with the government was an important piece of it, but also in just offering people a place to go. In some cases, it's as simple as multi-story concrete structures. Not the best place necessarily to ride out a hurricane, but it sure beats being enveloped by the storm surge. At least there's a way to literally rise above it and be above the high water line in a stable structure. And also to coordinate people to simply move inland, which is probably a better option when it's available. So globally, there's success stories here, and in the U.S. and in other wealthier nations, there's just an expectation that people get moved out of harm's way. But as we saw with Irma and other storms in recent years in Florida, that just doesn't always happen. And we certainly saw that in New Orleans, to really just devastating effect with Katrina back in 2005, where the final death toll remains unknown, but it was likely over 2,000 as a result. So, fortunately, Helene is not going to be Katrina in that sense, because it is not hitting an extremely storm surge vulnerable major city head on. So that is the good news. But the bad news is we're getting comparatively lucky this time, but next time we won't be necessarily so lucky. And even with this storm, there's going to be a huge toll in these coastal and near coastal communities that may be literally wiped off the map by a storm surge and wind of this intensity. And also really concerned about that catastrophic inland flooding across the southern Appalachians, as well as the surrounding area, where they could see as the Weather Service is calling for widespread catastrophic flooding that will probably be historic over a wide region with major landslide activity. So that's the Helene story. The John story in western Mexico, again, not a big storm surge or wind event, but another catastrophic flood event. And we are seeing more rapidly intensifying hurricanes in a warming world. We're also seeing wetter hurricanes in a warming world, which maybe is something I should have led with, because that is actually the clearest thing that has already changed with hurricanes, is that they're producing heavier and more intense rainfall. We know this. It's been observed. It's clearly linked to climate change. It's clearly linked to warming ocean temperatures, which, of course, we're seeing widespread catastrophic flood event associated with record warm oceans and a borderline category 4, category 5 hurricane. Again, these things are connected, and the great irony is when I have folks tell me, now is not the time to talk about climate change. Now is not the time to talk about record-breaking ocean temperatures. Even though this is directly, causally implicated in why these storms are as wet and or as intense and or as rapidly intensifying as they are. That is just the way things are. Is it the only factor at play? No, of course not. Have we seen Category 4 and Category 5 hurricanes before? Absolutely. Did we see them before global warming? 100%. But that's not really the question at hand. The question is, are we seeing storms of this extreme intensity to a greater extent than we used to? Are we seeing storms that can produce these extremely heavy rainfall, record rainfall events more frequently or with greater intensity? And the answer is yes. And so it just, frankly, is very tiring to have that conversation over and over again, because there's this notion that there's nothing new under the sun. And in a certain sense, that's true. Most of the possible weather events that can occur, even in a greatly warmer world, have occurred at some point over the past couple of billion years of Earth's history. I don't think no meteorologist or climate scientist would argue with that. But there's a lot of those events that I would rather not experience, and if we're seeing more of them on the top end of the scale than we used to, that's potentially a big problem, because, I don't know, a billion years ago there weren't too many cities on whatever the continental configuration was where the Gulf of Mexico currently is today, for example. So I'm seeing some updates. A couple folks saying that the pressure's down to 938 millibars. If that's true, wow, this thing has really just bottomed out in a pretty scary way, and it is probably making a run at Category 5. A lot of folks said that was unlikely, but again, just like I've said recently, we've seen a lot of wildfires in recent years doing historically remarkable or even seemingly implausibly extreme things. We've seen that also with rapid intensification of hurricanes like this, and I would not be that surprised if there's a last-minute advisory from the National Hurricane Center suggesting this has either approached Category 5 status with like a 150 mile an hour sustained wind borderline assessment, or maybe even on the on the other side of that in the postseason as a Cat 5. So first, this session will probably run a little bit long, so I'm not going to end this right on the hour since there's a lot of people watching and there's a lot to talk about. But I do want to just take a moment to take a sip of water and take a look at some of the questions first. So yes, as a lot of folks have mentioned, this is focusing more on the southeastern U.S. than the western U.S. And I do this occasionally, even in a global context, when there's a weather event of particular note or particularly extreme magnitude. It helps if it's in a time zone where I can show it, where folks on the West Coast are able to view live. But in this case, I might have done it anyway. Yes, Mason Cooley mentions that, asks if mountains of western North Carolina is part of this discussion. I would say absolutely yes. In fact, unfortunately, I think that may be where some of the worst effects of this storm, believe it or not, ultimately end up being. Not from the wind, and obviously there's no storm surge in the Appalachian Mountains to worry about, but the amount of water, tropical moisture that's inbound and going to be squeezed out by that upslope flow on the southern and eastern slopes of the Appalachians is just really, frankly, a scary amount of water, especially given that there is already record flooding occurring before the storm begins. So it sounds like the rain has slowed down a bit relative to what it is earlier, but unfortunately, much worse is yet to come, and the rivers are going to respond awfully fast. Comment that microphone gain is a little bit low. This does seem to vary a lot from people's system to system. I have to keep it low enough that it doesn't blow out anyone's speakers. That's been a problem before too. So hopefully it's not extremely low and you can just turn up the volume a bit on your local device. Hello to all the folks from San Francisco and Half Moon Bay and other parts of Northern and Southern California and Central California, Pacific Grove, Monterey. Well, depending on whether you're a Southern Californian or Northern Californian, whether or not Pacific Grove and Monterey count as Central or Northern California is perhaps a question of whether you divide it into 2 or 3 pieces, but that's a debate for another day. I know there's some very vociferous opinions on that front. Oh yes, Robert asks, would love to hear your take on how the hurricane will behave. I'm assuming the hurricane meaning Helene, making landfall in Florida as we speak, will behave while pushing onto land. Well, again, I'm going to show some more live data and imagery in a few minutes after I get through the comments here, so you'll be able to see this to a certain extent live. But this is one of the concerns about the storm is it's got fast forward motion. It's a borderline Category 4, Category 5 storm, so it's pretty close to the top end of the intensity scale, but it's also moving quickly. This is not a slow-moving hurricane. What this means is that this hurricane is moving fast towards the coast. It has very warm, record warm, bathwater-like warmth of the Gulf of Mexico to draw strength from all the way up into the point where the entire eye makes it over land, at which point the storm will start to weaken, and it'll weaken relatively quickly. The problem is if you're starting out with winds of 140 miles an hour or so, and you're moving really fast, even if it takes only 6 hours or so to weaken to minimal hurricane strength, this storm is going to be inland across Georgia by that point. And so a lot of places well away from the coast are going to see sustained hurricane force winds in a way that is highly unusual for a hurricane. Even a Category 4 or 5 hurricane, usually those winds attenuate greatly as soon as it moves inland because, again, hurricanes, they are classically a heat engine driven by oceanic warmth. Once you remove that oceanic warmth from the core of the storm, it doesn't have energy to survive anymore, so it rapidly falls apart. This is why California, well, this is one reason why California doesn't really see them, by the way. In this case, though, that's still true, but it's going to be moving inland so quickly, it just won't have time to fully fall apart. before bringing sustained hurricane force winds perhaps as far north as the southern suburbs of Atlanta, which is really, really far inland. This is, by the way, why Tropical Storm Hilary made as much of inroad as it did towards Southern California last summer. Obviously, a different scenario here. It was a weakening tropical storm rather than a weakening Category 4 or 5 hurricane. But this is the same story. It was moving forward very quickly. The ocean temperatures off the coast of California were nowhere near enough to support a hurricane to develop or maintain its strength, but the storm moved so quickly northward from areas where the water was warm enough for that to happen that we did in fact end up seeing borderline tropical storm conditions as the center of circulation survived the trek into Southern California, and even though it wasn't officially a tropical storm at that point, moved right over Dodger Stadium. So that is also sort of I would not call that necessarily a nightmare scenario, but a plausible extreme scenario in the future with slightly warmer Southern California oceans, maybe in a particularly strong El Nino year, where the oceans are even warmer than the long-term average, where it might be possible, once again, to see another San Diego hurricane. This did happen, as far as we can tell, in 1858, and it could happen again, but it would probably have to be a mechanism like this. A particularly warm year, perhaps an El Nino year, a couple decades in the future with some more long-term ocean warming, with a strong hurricane off the west coast of Baja California making a beeline northward for Southern California and just not having the time to weaken fully before it makes it to the coast. That's sort of the process model for how that might happen if it happens, and I know that the Weather Service has actually war gamed that scenario out a bit. It's not as extreme as it sounds in some ways, but not radically different, in fact, from preparing for a high-end winter storm or atmospheric river, but nonetheless notable that there is a little bit of an analog here, that even in the southeastern U.S. with a dramatically warmer ocean, the same mechanism still applies. Once you remove the adequately warm ocean that's providing that hurricane fuel, the hurricane just tends to fall apart pretty quickly. This one will fall apart less quickly than usual, though, because it's moving so quickly and is so intense to begin with. So there's a comment that kinetic energy increases nonlinearly with wind speed, and that is correct. So this is one reason why, even a 5 or 10 mile an hour increase in the winds associated with a hurricane, or really even just any storm, so even if it's just an ordinary winter storm in California, there's a big difference between 50 and 60 mile an hour winds or 60 and 70 mile an hour winds. There's not that big of a difference between, 10 and 20 mile an hour winds or 20 and 30 mile an hour winds. None of those really cause too many problems, I guess, unless you're dealing with a wildfire or something, or you're on a small sailboat perhaps. But once you start getting, higher and higher, each 10 mile an hour increment is a pretty significant increase in the force exerted by the wind, and therefore in the wind loading on structures. And so the civil engineering curves to build structures to withstand extreme wind speeds, this is one reason, by the way, why even if the most extreme hurricane wind speeds only increase by something like 5 to 15 miles per hour in a warming climate, that is not a small number in terms of the major differences in damage that you might experience, or the design standards you would need to use to make structures equivalently robust in the face of extreme wind loading. So the difference between 70 and 80 miles an hour, perhaps not huge in terms of what you need to engineer, but once you start getting up, the difference between 130 and 145 miles an hour is actually quite large. And so once again, another example of a process that is itself, at least in terms of its impacts, highly nonlinear. Another reason why the extremes matter in a warming climate especially. Yeah, a few folks from around Asheville, North Carolina, commenting here, and that does unfortunately look to be right around where some of the worst rains may be yet to come. So really, I would not let your guard down, even if the rain is lighter tonight. Get a bit of a break before the worst hits. Yeah, as that points out, so the wind force is not necessarily exponential, but it is still nonlinear. It's somewhere between, well, the force itself is indeed sort of a quadratic function. The damage can be something even steeper than quadratic, but that's a little bit different. But the point is, each additional mile per hour exerts disproportionately more force than the last. So once you start talking about differences in the 5 to 10 mile per hour range at the very high end of the scale, those are not small differences in terms of the impacts. Yeah, the Mary mentions that there has been advice to treat the eye wall of the hurricane arriving essentially like a tornado, and in this case, that's exactly what you'd have to do. Except it's a tornado that is 100 miles wide and could last for hours, unlike a typical tornado that's usually a fraction of a mile wide and lasts just a minute or two. Uh, and that's entirely right. I mean, if there really are winds of 140 to 150 miles an hour at the surface, which look likely, that's a pretty strong tornado. That's somewhere in I think the EF3 tornado range, I believe. Yes, thanks for folks being patient earlier when I had to deal with the person who came in and disrupted. This particular individual I've been dealing with for 15 years, believe it or not. And I'm not the only one. It's a well-known name in the weather and climate community, let's just put it that way. Also a name that's known to the FBI. That's all I'm going to say about that tonight, but let's see here. There's a question about, I was mentioning the extremely warm water on that ocean temperature anomaly map, the Kuroshio extension in the Western Pacific. We do know that that is a region that is likely to see much warmer water in a warming climate. In fact, climate models, coupled Earth system models, suggest that this will be a hotspot region of accelerated warming. I actually need to look into that a little bit more exactly to explain the mechanisms, but we do know the western boundary current regions may warm faster than the rest of the oceans. They are good accumulators of heat. In the North Atlantic, this is challenging because the North Atlantic overturning circulation might be slowing down. That would be part of why the North Atlantic western boundary current would be warming preferentially the eastern seaboard and resulting in accelerated sea level rise there if that overturning circulation slows. Stay tuned, by the way, for a documentary that I've been heavily involved with that'll be coming out soon. I'll talk about that a little bit later, that will talk a lot about that potential risk in a warming climate. But we do know that these western boundary currents, these warm western boundary currents, are accumulators of heat and energy in the oceans, and there is some faster accumulation of surface ocean heat in these regions relative to other regions. We see that now both in the real world as well as having seen that predicted by climate models. So it's actually another spatial fingerprint of oceanic climate change that is validated by the pattern that we see in the real world. So yet another sort of quirk that could have turned out to be just a weird thing in model land, but actually appears to be developing also in the real world, which is, I guess, good news for the oceanographic modelers out there who've coupled their models to climate models. Maybe not so good news if you live in Japan. There's a question about why or how Helene's path was so well predicted. This was a particularly well predicted hurricane path. It's partly because, in this case, there was clear steering flow, meaning that sometimes hurricanes, when they're in a weak flow environment, winds aloft could be as weak as 5 to 10 miles an hour and kind of in a variable direction. When winds are that weak, the hurricane is kind of like going to drift around. So imagine an analogy. You see a leaf fall into a pond. It floats on the surface. Can you predict, in the absence of a strong wind, where that leaf is going to sort of blow, where it's going to drift on the surface of that water? Probably not with any accuracy. Now, if there's a howling wind blowing from one direction, you're probably going to predict that the leaf is going to move with the wind and end up on the other side of the pond, right? That would be a reasonable prediction. But if it's a dead calm day, there's just going to be these random eddies and swirls and these brief wind gusts, and the leaf is kind of going to take its time and move erratically. That's pretty much analogous to why some hurricane paths are easier to predict versus others. Some, they're strong steering winds, as is the case here. In fact, they're very strong. This is why the hurricane's moving so quickly toward the coast. But in other cases, that's not the case. That's not so, and those hurricane paths can be extremely difficult, if not literally impossible, to predict more than a couple of days in advance. So this is one of those storms where I would have expected that the path prediction is quite good. There are other storms where we could have predicted in advance that the path prediction would be highly uncertain or poor. And that is indeed now a new feature of the National Hurricane Center. Predictions is a dynamic estimate of just how precise the path forecasts are likely to be. Interesting reflection there. All right, thanks for the comments. I'm just catching up here on some of these things. Lulu mentions at some point there was a 183 mile per hour reading on the Doppler velocity that I was showing earlier. I'll take another look at that in a moment. But I believe it, and that means this thing is inching closer to Category 5, especially if that 938 millibars truly is truly correct. There's a comment that hundreds of people in Taylor County have told officials they decided not to evacuate. I don't know exactly where Taylor County is. I'm going to quick Google it in the background just so I can see. Yeah, that's not great. That's actually, yeah, that is really not great, because that is the county, the low-lying county that is going to probably be right where this hurricane makes landfall. So I certainly hope that at least if those folks didn't leave, that they're above the storm surge line. You can survive an extreme windstorm if you're careful, but if the water's 20 feet above your head, I don't know there's a lot you can do about it. So fingers are crossed that folks are at least above that 20-25 foot elevation mark if they haven't left. Still going to be a rough ride anyway, but I think it's probably too late to leave at this point. There's a note that Tropical Tidbits is back up. I'll take a look and see if I can pull up the other imagery here. There's a question about why hurricanes can't form over swamped, humid land like they do over oceans. That's an interesting edge case, because it turns out that they generally can't form over those regions, but they actually can, in some cases, maintain their strength. A colleague of mine, I believe it was Marshall Shepard, coined the term the brown ocean effect, which literally means this notion that you can have land that is not quite land in some places, that is very swampy, very water-filled. This is particularly true in areas with extensive wetland and marshes. This would be true of places like southern and southeastern Louisiana, where the land is really more water than land. If you've ever been there, you know what I'm talking about. This is true of parts of some coastal regions, the deltas in South Asia, Southeast Asia in some cases. And it can be true over some low-lying inland areas in the wake of a hurricane. So there's some examples of tropical storms or hurricanes maintaining their strength over land in the southern U.S. because they push so much seawater inland that inland became like the sea temporarily, and so that warm water is now sitting a few feet deep, flooding previously dry or dry-ish areas. The combination of freshwater flooding plus ocean flooding can actually self-perpetuate a storm. So essentially the storm creates warm ocean ahead of itself, by virtue of flooding new areas. Now that's kind of a dramatic example. There have been some other examples, even I believe in some places in the Australian outback. In the northern Australia, you can actually get an intersection between where the edge of the outback is and where there are tropical cyclones that can make inland landfall. So there is a theory here known as the brown ocean effect. An interesting name, but it really does kind of describe what is going on here. And it's usually not enough to cause storms to form, but on the other hand, it definitely can influence the storm's rate of weakening or maintaining their strength in unusual cases. So it's an edge case, but it can be an important edge case in a few instances. I don't think we'll see any of this here, though. This storm is moving way too fast inland. It's going to be near Atlanta by tomorrow morning, so... All right, so I actually want to, before I wrap up shop, and I appreciate there's actually still quite a lot of people on, so thanks for sticking around. One thing I just wanted to mention, for the sake of the channel, since I got a lot of you watching, and I promise I'll show us more radar and satellite before I close, is it's really helpful when folks share these live streams, and if you like the channel or subscribe to it. The algorithm likes it when people like these individual videos, and it also likes it when people subscribe to the channel. The bonus, of course, being that you're notified when I have these sessions, and occasionally I will do pop-up sessions, as regulars can attest to, on very short notice that you might not hear about unless you're already subscribed. So I would strongly encourage folks to do that if you've enjoyed this one or other sessions previously. Okay, and I'm going to switch my screen over once again. You'll briefly see the infinite mirror before I transfer over to satellite. Man, oh man, oh man. I'm going to pause it on this last frame because in some ways, this very last frame is the scariest one of the entire bunch. Okay, I guess I can't pause it because this website is still running slowly. That's okay. You get the idea. This is live. This has updated a few frames since we've been talking. The northeastern eye wall is now making landfall right along here. That is bad news because that's exactly where the county where several hundred people apparently refused to leave. So, I mean, I just hope that folks are at least 25 feet above sea level. That's all I got to say there. Tallahassee, again, about right here. Still looks like it might just brush the western eye wall, which is the weaker side, but there could still be 100+ mile-an-hour winds in it. So weaker is, of course, relative. But this storm is going to be moving up towards Atlanta by tomorrow morning, as I mentioned. But man, this most recent frame, this last frame, look at that eye. It's almost fully cleared up. So that really isn't what we wanted to be seeing. Let me go over and now share some radar. So as you can see, I left this radar where the storm is in the center of the image. Since I left it, it's moved north. Unfortunately, so this will show this is the county here. I'll draw an outline that was mentioned as folks having not evacuated from. So that's, as you can see, the hurricane is now making landfall. The eastern eye wall is either over or just about to be over Steinhatchee, Salem. It's going to move through Perry. Perry is a significant town for the region. It's probably, I think it's Perry is the largest town in this county. Fortunately, Perry is above the storm surge line. We might get storm surge all the way up to just south of town, so this whole region is likely to be part of the ocean tonight. And as you can see, things are going downhill pretty fast in Tallahassee. It still looks like this system, it's moving almost due north, so this is the part of the eye wall that might scrape Tallahassee as it goes north. But boy, there is still lightning, not as much as earlier, but there's still lightning in this eye wall as it just about comes on shore. Still seeing, again, these mesovortice type features. If we pull up the You see that, these serrated sort of edges. Look at that. So you see these. It's almost looks like a bit of like a saw blade. It's a bit on the nose, but I mean that's what it visually resembles. Just looking at what some of the values are in here. I need to pause it and go back in time a little bit so I can just see. Yeah, like winds up in the 160s. So, it's in the western eye wall. Yeah, so this is a very, very powerful storm. I suspect it's going to probably remain most likely just under Category 5 strength, but man, the impacts are not that different for a high-end 4, low-end 5. This is certainly a historic storm, probably the strongest hurricane to hit this stretch of coastline in recorded history, and is likely to bring, as I mentioned, historic flooding inland, including as far north as western North Carolina. But that is just one hell of a storm. Yeah, look at that eye. I mean, that is, it's almost perfectly, I can actually draw a perfect circle to show. Actually, that's the wrong. Let me just try and see how perfectly circular it is. I mean, that is pretty darn close to a perfect circle. Let me actually draw it a little bit closer to the center. I mean, look at that. That's essentially, that is as close to a perfect circle as we get in nature in this context. I mean, that is, and by virtue of doing this, you can see how large the eye is. So the radius is 15.5 miles about, let's just call it 16, because I think I'm underestimating it slightly on the south side. That's essentially a 32-mile wide eye. So if you're in the middle of this, if you're in this region, at the center of it, the wind is calm. You can see the stars. The skies are clear. There's probably a lot of confused seabirds. In fact, we often see that. We'll see seagulls that circle in here and sort of translate with the storm. They get stuck because, of course, you can't land anywhere. So you have to keep flying until hopefully you reach land or the storm weakens. So good luck to the likely numerous seabirds that are flying around in circles in here, and also to anyone who's on this segment of coast. It's going to be a very, very long night. But this is a truly remarkable satellite image. I mean, it is this is definitely something that will end up in a textbook somewhere. All right, well, let me bring the screen back up, and I think it's probably about time to close for the night. But let me just see if there are any last minute questions here. There is a comment now already that the storm surge at Cedar Key, which again, actually if well, it probably isn't super important, but Cedar Key is on the southeastern flank of the storm in that region I was just indicating, that the storm surge there is already higher than the previous record during Idalia, a recent hurricane that was also very intense. So just pointing out, this storm is likely worse than that one in almost every respect. So I think there's going to be big problems. I mean, this is like a geologically altering storm surge potentially. I suspect that portions of the Big Bend, Florida coast will look permanently different after this event recedes, and also a major catastrophic flood event up in the southern Appalachians. So those really are the two regions I think that are of great concern here. And this will not be over today. This will continue into tomorrow. And if you know folks in the southern Appalachians, this is one of those events that will be completely outside of their historical experience in all likelihood, and likely the experience of their parents and grandparents before them. That happens more these days than it used to, that's for sure. All right, folks, I hope this session was enlightening And the next one will be back in California. But right now, because there is no extreme weather to talk about at the moment in California, other than what appears to be another unusually prolonged warm and dry spell in the next couple of weeks with rising fire risk, I think I'm going to call it a night for now. Stay safe out there, and talk to you next time. Thanks for watching.